So again, welcome everybody. My name is Revay, or short form is Gary, because that's easier to say. And I will be talking about the cross-origin resource sharing. If you were here yesterday for the HTML5 talk, where the legacy features and the HTML features were compared, that I will extend the cross-origin resource sharing part a little bit. So I will go deep in this feature. A bit about myself. I work as a penetration tester at the moment for Siemens, and but yeah, as you can see here, this talk doesn't really have anything to do with Siemens. It's just things what I experienced during test and during my own time. So, first of all, I would like to suggest a game. I don't know whether it's appropriate now, but I will still explain, and you can choose whether to play or not, because this is a drinking game. The whole point is that all the time when I say the word request, you drink, preferably an alcoholic beverage. No, sorry, I wasn't prepared. And I feel bad that this is the last talk, because you could have played that for the whole conference. Yeah, the thing is that this is a talk about HTML and web and things like that. So I will say request a lot, and yeah, you will see. So what's the talk really about? First of all, I will explain what courses I will call cross-origin resource sharing course, because it's a really long stuff, and I don't like long words and stuff like that. So I will just call it course. I will introduce course. I will explain how that worked before. So what were the pre-course solutions? Then we start to dive into the security part, first by talking a little bit about the attacker. And then we will see what are the problems here regarding security. I will show some attack scenarios. And to be a good cop a little bit, I will just introduce the solutions to the previously discussed problems, and then I will try to show you some demos. So, cross-origin resource sharing. Already said that it's an HTML5 feature. It's part of the XML HTTP request, so it's in JavaScript. And the main point, of course, is that you can talk with other domains. So there was a business requirement for that. So in the old times, you had your website and you had all your contents on your website because it worked. But nowadays, people like to store different content in different places because of some reason. So for instance, you want to store all your files, your CSS and your videos on another server, because that's faster, or because it's in the cloud and you get unlimited storage. Sorry? Oh, sorry, I thought I heard something. Oh, all right. So because of unlimited storage. But the point is that for some reason you want to separate your business logic, where your application runs, from actually the content, what you're loading. So that's basically a really simple architecture. So here you have your business logic. That's the place where the client communicates with, and on the other side you have your content. So like the videos, for instance. And generally we had the same origin policy here. So the same origin policy stopped us from taking content from another domain. And that was a problem for people, because they couldn't implement this business case, this business scenario. So, of course, when there is a business scenario, then developers will do something to implement it. So it was the case with this problem as well, that developers found solutions to them. They were mostly hacks, not security hacks, but like development hacks. For instance, you could have a proxy in your own domain that will request the data from the other domain and then return it to the user. I think you see that in this case, for instance, you lose some of the benefits of having your content in another domain, like speed, for instance. But it works. And there was also JSONP, which is the JSON with padding. So this example is the JSONP here. And what JSONP exploited is the fact that HTML tags were able to actually send requests to other domains. So you could download your script file, for instance, from other domains. And so developers started to use that one. For instance, here, you see this is a script tag, and it goes to this URL, and they built kind of APIs using this JSONP. So here you see that it requests some kind of users, and there's a number after it, and here is a function. So what here happens is that this is the users, and it's requesting this user ID. So probably you will get some kind of user details or user properties and something like that. And this function here, that's a callback function, because what happened is that for this GET request, you would receive this response. So here you have the data what you requested, so the user details, wrapped around with this callback function, what you defined here. The point with that is, since it's wrapped in a JavaScript function which exists on your site, this script tag can immediately execute it. So you get the data, and then you can do whatever this function does. It works. That's obvious. It also has some limitations, but so it solves the original problem of not being able to go to other domains. But I think you can see that it's really kind of a hack. So it's difficult to exploit it, but still it's ugly, you know, like sending a request, telling what function to send back, and so it's a bit weird. You can exploit it if you can do man in the middle, because then you can change this function, because you can just do whatever JavaScript you want here. But that's only the man in the middle case. But still, it's an ugly thing. But then Course came along. So Course came along to fix this problem, to provide a solution for the business problem and make it also secure or regulated in some way. So what Course does is there are lots of different decisions to make. Mostly the browser has to do the decisions. And the first thing to decide is, so there are two kinds of requests defined by Course. They are not renamed really well, because I'm going to call them what is the simple request, and the rest is the not simple request. And the browser will have to make this decision. So what is happening, you make an XML HTTP request in JavaScript, and you want to send it to another domain. So you execute the send function, and then the browser has to decide first whether this is a simple request or not a simple request. So how does the browser do that? It's actually not that difficult, because the simple request is very strictly defined. That's the definition here. So the simple request can be a head, a get, or a post method, and it can contain these headers, and it can be these three content types. Anything which doesn't comply with these requirements is not a simple request. So when you want to send your XML HTTP request, the browser will check it. If it complies with this, then it's a simple request. If not, then it's not a simple request. If it's a simple request, then the browser will just send it out. So then it's business as usual. So it will send the request, get back the response, and provide the response to your JavaScript code, so for the client, basically. If it wasn't a simple request, so for instance, it was a put request, which was not in these three methods, so not in these three allowed methods. So if it's a put request, then the browser essentially has to ask the server whether these kind of requests are allowed or not. And this is how it happens. So this question, so how the browser asks the server, is called the pre-flight request. So the browser will send a pre-flight request to the server, and telling the server that I have this kind of request here, so defining what kind of request is that, and then the server can decide whether such a request is allowed or not. And then the server responds with the pre-flight response, and if the browser sees that those things which were asked for, so for instance the put method is allowed, then it will just send the request what you asked for to the server, and then it's business as usual. If it's not allowed by the server, then the game is over, and your request will not be sent at all. So it will never reach the server. And this pre-flight request is not really complicated, actually. It's an option request, and it has a couple of specified headers. So it has to have an origin header. The origin is the place where the JavaScript runs. So it's the domain where the JavaScript is. It has some kind of access control request headers, and these headers will define what was the request, what you wanted. So if it's a put request, then it will say here put. If there is a funny header which is not defined in those four which I showed you, then it will also say that the request contains a funny header. So all those things which is different than a simple request will be defined here. And based on that, the server can decide whether your original request will be allowed or not. And the server just sends a response containing other access control allow headers, telling the browser essentially that this origin is allowed. It can be more, so origins can be listed here. And these methods are allowed, and these headers are allowed, and these content types are allowed. So anything which is related to the request, whether they are allowed or not. So this response goes back to the browser, and then the browser can look at it and say that, okay, so that's cool. We wanted to send a put request. Put is allowed, and we wanted to use this custom header, and it's also allowed. Then great, we can just send out the original request. So then your XML HTTP request is successful. So it will be sent, and you get back the response, and you can work with the response. So that's basically how course essentially works. Do you have any questions to that just before going forward? Sorry, what? What gets sent back if pre-flight denied? So for instance, in this case, it's... Oh yeah, sorry. The question was, what happens if the request is not allowed? And so, for instance, imagine here that we wanted to do a delete. Then here would stand delete, and then you get back this response. The response will be the same, because the response is essentially saying that I allow this. And since delete will not be there, then the browser will kind of drop your request. So it will not be sent at the end of the day. So that's all.
The pre-flight request is to ask the server for the policy. What my browser supposed to be sending? The request is actually just sent, but in the response, the server still says what is the access control law origin. To let the browser know if he's supposed to forward that response back to the script or not, right?
Yeah, so the question or statement actually was that in case of a simple request, the server will still say that what kind of origins are allowed, and that's true. So if it's a simple request, the request will be sent, and the response you get the response, and I will talk about this later because it's really interesting. The server sends the response, and there will be this allow access control allow origin header that will be there, telling the browser which origins are allowed, and then the browser still have a last decision to decide whether to show the response to the client, to the JavaScript. So that means that if at the end the browser still thinks that this request shouldn't have been allowed, then it will not show the response content to the JavaScript. But I will still go into that later. Yep.
How are cookies handled in this scenario? Are the cookies sent with the
I will talk about that. The question was how the cookies are handled. You can ask the browser to send the cookies, essentially. I will talk about that.
So my question was specific to the pre-flight.
No, there are no cookies. So in the pre-flight request, there are no cookies. Yeah. So attacker model, I will be quick because it's pretty general. That's like the most basic web attack architecture. We have an attacker sitting somewhere. He has a malicious server. We have our target users here browsing the web, probably in a network of a company or something. And there are internal and external targets, what the attacker want to reach. So so it's basically if you want to do some kind of risk assessment or something, what to think about your attacker, how to define your attacker. So the first attribute of the attacker is what kind of knowledge he has. He can be, here I call it internal, external, but here I mean that the knowledge what he has about the target services. So for instance, the internal attacker could be an ex-employee who actually knows what he wants to get. So he knows exactly where the roadmaps are or where the plans are, what he wants to steal in the internal network. So he has the knowledge, opposed to the external attacker who doesn't really know what he wants. He wants to have access to your network, but he doesn't know what he wants to steal. He wants to go in and look around. So that's an important difference, because the internal attacker who has the knowledge, he can take the data much faster. Regarding the goals of the attacker, of course, the first is to get some kind of access to this company network, to this internal network, using CORS in some way, and attack the internal services. So what you've seen on the pictures, the different internal services, and essentially steal data from the user himself or from the company through the user. And there is also a location difference for the attackers. There are the internal attacker, like your colleague who sits next to you or sits the other side of the world, but also in the same network. And there are the attackers who are sitting outside in the internet and really wanting to get into your network. So that was all what I wanted to say about the attacker, because I think you already heard lots of things about that. But with these attributes, you can, when you're evaluating your services, or then you can try to define what kind of attacker you're facing with, and how should you protect against those specified attacker models. Yes. So here you see two things. One is why I didn't go to the photoshopping industry, because I'm not really good in that. And the other is what's really the problem with CORS, because it's actually a nice feature, but there is one catch here, and it's the fact that it gives a new opportunity to get around the same origin policy. So until CORS, the same origin policy was really cool because it was really strict and really stopped lots of different attacks. But CORS gives a small chance to the attacker to circumvent the same origin policy. But at this point, I would like to emphasize that CORS is not really a broken feature. So it's not like it's a vulnerability. It's just a tool what the attackers can use sometimes. I will also talk about the limitations, but it's really just a tool what you can use in some cases. So I think Course was really designed with security in mind. So if it's configured well, then there is no problem. The problem comes when the configuration is wrong. Then the attacker may be able to exploit it in some scenarios. And we will talk about the scenarios. But first, are you generally familiar with the cross-site request forgery? I think so.
We've heard of it.
All right. Because I just wanted to recap it quickly, but then I will just really fast. So attacker makes a malicious website with the content to post, for instance, on this server. Imagine that Facebook is here and he wants to post something on Facebook in your name. The target user browses the malicious website, and if there is no protection, then this website will send a request to the target server to actually execute the action what the attacker wanted, in this case to post in your name on Facebook. That's basically the CSRF attack. And why I said it is because Course is mostly useful in cross-site request forgery attacks. So it really helps a lot if you can use JavaScript, because Course means essentially that you can use JavaScript in your attacks, in CSRF attacks. So just a few ideas. When can you use it? For instance, multi-stage CSRF attacks. Imagine a web shop. When you're buying something, you choose the product, put it in your shopping basket, fill out the delivery address, and your credit card is already filled because you're logged in, and then you click on checkout, and that's it. So you need to do at least 3 things to do a successful attack against this web shop to buy something. So if you cannot use JavaScript, then it will be pretty difficult because you have to hard social engineer the user to do so many things for you. Like do actions for you, because you need to do 3 actions at least. But with Course, you can exploit JavaScript in this case. So you can use JavaScript to do all these things. And since it's a web shop, you can really prepare your attack. So you can go there, look at it, how to do that, prepare your JavaScript, and then when the user goes there, it just happens. So that's how you can exploit it. And the second case is the cross-domain data theft. That's like really basic. That you go into through the user, you go into the network, take out some data, and send it back to you. Because you can use JavaScript, that's again really simple. You download the data and send it outside somehow. For instance, if you know the Beef framework, so the browser exploitation framework, they also use Course when they exploit some other server and they communicate with this server. They exploit the fact that they can do that because of Course. There are already some tools on the internet which you can use to do network enumeration based on Course. It's not really, so it's a kind of Nmap, but it's not like that. So it's mostly heuristics to decide which service is up and which is not. It's based on timing and things like that. But still, Course still allow you to send requests to different servers and to see what they are responding, and based on that, do some kind of enumeration for you. So that was also another example. And the last thing, I have a very sophisticated slide for that, is the file upload CSRF. I was doing a pen test of a very simple application, which was actually a login page and a file upload page. That was all. So that was the whole application. So obviously, I wanted to do some malicious file upload, and I tried that. So I tried to craft an HTML form to create a file upload request. So when you use the file upload form of HTML, then it will send a multi-type request to the server, a multi-type post request. So I tried to mimic the same with a normal form, so not a file upload form, but a normal form. And it turns out that I couldn't do that. Maybe I didn't do well, so if you can do that, just let me know. But the thing is that the file upload form, if you use the file upload form, it will put here this file name attribute. And you cannot really do that with the normal form because you don't have so much influence on the content of a form which creates a multi-stage request. So you will not be able to put this attribute here. And because of that, or in my case, it didn't work with the server. So it didn't like my request. But using course, that's not really a problem anymore because you have JavaScript. So you can create whatever request you want. So this is a proof of concept code for this file upload. So what you see here, this is an HTML, and here is the JavaScript, and essentially I create this multi-part request with JavaScript, and here you can see that this is where I put this attribute line there, so this content disposition line there, which I couldn't do with the normal form. So with this JavaScript code, you can create the same, exactly the same request what would be generated by a file upload form, an HTML file upload form. And then, of course, because it's JavaScript, this will do a submit button, but it's not necessary, so you can do it without user interaction. And funnily, when I was doing it at first, I implemented it myself, but it turned out that Burp, so Portswigger just released a new Burp version the day before, implementing the same functionality. So now, if you're using Burp Pro, and you have like something like this, and you click on to generate proof of concept, so CServe proof of concept, then Burp will generate the same thing. So this is a Burp generated proof of concept actually. So with Burp, it's pretty easy now to do such things, and then you can change it if you want. But the point is that because of course we could exploit this issue, what was not exploitable before course. Oh, here's my favorite GIF, but yeah, LibreOffice doesn't like it. Anyway, so we have, as I said, this is not a broken feature. It's a well-made feature. So we have to fight as a penetration tester. We have to fight with different limitations. The first one I like to call is the write-only request, and that's we get back to the point what you asked. So in some cases, when something goes wrong, you still get back the response from the server, but based on the last decision of the browser will not show this response to the client or to the JavaScript. It's actually pretty interesting. Even if you use Firebug, you see that you got the response. You see that it's 200 OK or something meaningful. You see that you get back the response, but even in Firebug, you cannot open the content. So it will be empty. And it's because of this, because the browser will not allow JavaScript to see the content of the response. And these, what you see here, these are the cases where I experienced such a limitation. And the first one is there is no access control allow origins header in the response. That means that course is not enabled on the server. So the server doesn't know anything about course. In this case, the browser will say, oh, sorry, this guy doesn't know anything about course, then I don't allow the request, the response to be seen. That's the last line of defense. The second is that the source origin is not allowed in the origin header. That's what you asked, that that you send a simple request, you get back the response, but your origin is not allowed actually. Then the browser still says that, okay, sorry, that was my fault, but you cannot get the content. And the last one, it goes back to you with the cookies. So you can, there is this with credentials that's part of the XML HTTP request. So you can say XML HTTP request dot with credentials is equals true. That means that you're telling the browser that please, with this request, send the credentials. So the credentials are the authentication headers and the cookies. So now you can do that. You can tell the browser to send the credentials to the other domain with the request. That's also a pretty interesting thing. And this line is really important. This line says that if you're using with credentials and you got back the response and this access control allow origin is set to all domains, so all domains is allowed, then it will not show the response to the JavaScript. That's really important because if this requirement wouldn't be there, then the CSRF protections what we are currently using, they would be more or less useless in this all domains settings. Because what you could do is you could send a GET request. So CSRF protections, I mean that using some kind of random token in the form. So random token is built in the HTML form, and because of that, the attacker cannot create a fake form with the correct token. So, but in such a case, so if this wouldn't exist, then the attacker could send first a request for the whatever checkout page, get the form with a correct CSRF token, and from JavaScript take the token, and with that create a valid post request to submit this form. So this would circumvent the currently used CSRF protections. But so we are actually lucky that this exists. This says that if you're just sending a simple request and credentials are involved, then all domains shouldn't be accepted. So then you wouldn't be able to get the tokens.
An access control origin to be the wildcard,
Mm-hmm.
and the browser wants to send.
Yeah, that's what I meant here, and that's why I call it write-only request, because it's very important that the requests are still be sent and it will still be executed on the server. So the action what you asked for will happen on the server. You just don't see the response. That's the point. So whatever you wanted to do, it will happen on the server. You don't see the response. I will speed up a bit because of the demos. Yeah, the second limitations, the pre-flight request fails. Actually, so in any case, when you deal with weird requests, some frameworks do that. They use weird headers and things like that. Then the pre-flight request will fail, and then there you cannot do anything. So then your request will not be sent. It's so simple. Yeah, here is the good cop part. Solutions. More awareness of the basics, of course. That's what I'm essentially doing here, because I think everybody should understand it at least in such a level that they can implement it properly. Be as strict with allow origin settings as possible. Think about whether you want to allow credentials or not. If not, then reject them all. So there is nothing really complicated with that. I think it's interesting. That's a bit of a change of a mindset. So these settings are both on the web server or web container level, and also on the development level. So you can either fix it on your or set it in the web server, like with Apache HTTPD, where you can use the mod headers and set it for different files and different directories. In this way, just simply setting the header. or you can do it in your application code itself. So like with ASP.NET, simply if some kind of resource was requested where CORS should be enabled, then set the header in the application itself. So demo time. I didn't want to sacrifice any cats and sheep for the gods of demo, so I recorded demo, so I didn't want to try it.
Were you eating a hamburger when you made these slides?
Why?
Because that would.
No, I'm vegetarian now. So this one is the sugar CRM. It's a CRM application. You can try it on the web as I did. What I want to do here, or actually it's Jane. We see here Jane. Jane is a regular user in the application, and but she doesn't like it, so she wants to be an administrator. And here in the other browser, this is the administrator. He or she, I don't know, is also looking at Jane's profile, saying that Jane is a regular user. So there is this weird cookie. It's actually, I didn't know that time. It comes from Amazon, so it's a load balancing cookie or whatever. I don't know exactly, but the weird thing is that it's only valid for 60 seconds. When I tried to use CSurf in this case, the only thing what stopped me was this cookie because it's valid for 60 seconds. You can send a request after that, and you get back exactly the same cookie. But that means, as an attacker, that you have 60 seconds to send your malicious request after the last refresh of the application, which is not too much. But CORS is going to help. Yeah, sorry, the background doesn't work really well. So this is the proof of concept attack. The long part is the request to change the user settings. That's why it's so long. And in the beginning, you see that I send just a GET request to the server. This is only to get a valid cookie for 60 seconds. That's the whole point. To send a GET request and with the response get back a new cookie, so that when I send actually the user the change request, then it will contain this cookie, and because of that, the request will be accepted. And there is an isAdmin parameter, and if it's 1, then you're going to be an admin. So let's see. User has clicked on something, and in Firebug you will see the request going. First, the GET request to get the cookie, and I think it was 3 seconds, and then the request to change the user attributes. So I will show that shortly in Burp. So here you see that in this GET request we didn't have the cookie. Then we got back the cookie in the set cookie header. And this made our next request, the post request, valid. So you see that in the post request, we have every cookies which are needed for the application, and also isAdmin set to 1, and the response is a redirect, which was the normal response for such requests in this application. So if we go back to the service and refresh our page, I just click on edit to refresh it. I see I click on it. Yeah, cool. And ta-da! Jade is now a system administrator. And then I go back to the other browser, that's Jane's browser, and refresh it again. So Jane also sees that she's now an admin. I was cheating in this case a little bit. Has somebody noticed it? What was the cheat? Because I talked about this with the sugar serum guys, and they told me that it only worked because I used localhost, so that my malicious file was running on localhost, and that's the only reason. And they are right, actually. And this also shows that even if you play with it, there are always surprises with cores, because it only worked because it was a local host, and if you're running a local host, then the access control allo origin header will not be filled properly, and that's the only reason why it worked with the server. It wouldn't work from a normal domain. Yeah, and that's the other example. This is a wiki because there are wikis everywhere. I think every company has a wiki. And I also have a wiki, and I keep my secret plans there, how I'm gonna take over the world. And the attacker wants to steal my secret plans. The wiki, actually, it's configured, so it's configured to allow all domains. And in this case, the attacker exploits this fact that I configured it wrong. So what we want to do is to create a website which will take this wiki and send out back to the attacker. And this is how it's happening. I don't know whether you see it actually. So this is an HTML page with JavaScript with two parts. The first part will request the URL from the wiki. Since it's a wiki, it doesn't ask for authentication to read the page. It only asks for authentication to edit it. So we don't need cookies to read the content. And the second part, when we receive the content, the second part will send it to the website of the attacker, to this writer PHP, which is like, never use this PHP code. It's like vulnerable to everything, probably. But what it does, it receives some content and it will write it on the disk to save it later. That will be the incoming.html. So let's see. So the case is the same. The user has to browse the page of the attacker. And it's an innocent page with ponies. But if you scroll on the image, then something is going to happen. Oh, yeah. And at the bottom, you see that there were 2 requests sent. Yeah, we will go to burp to see these 2 requests. The first request is we go to the wiki and get the super secret plan. You see, it's allowed for every origin. That's why we can read it from the response, and it works because it was not with credential. That's why you can read it from JavaScript. And then the second request just sends it back to the attacker, which was successful. So if we now try to load the incoming HTML on the attacker's page, then, yes, we stole the super secret plan. So what's the takeaway here is that using cores, we were able to smuggle out data from the internal network. And I think with that, I will finish this off. So are there any questions? All right, then, thank you very much.